Hope you're ready for some graphing. We are going to be graphing polynomial functions in this video. To begin, look at a polynomial function and see if you can factor it. It's going to make your life a whole lot easier. So notice in this function f of x, the GCF is 2x. I'm going to factor out the 2x. That would leave me inside these parentheses with an x squared minus 6x plus 5. Alright, let's see if we can factor that quadratic. So my 2x still is a factor in front there. Let's see, I'll try x and x, obviously, to give me x squared. Numbers that multiply to 5, 5 and 1, which is perfect because we want to get negative 6. So to get negative 6, I would make those both negatives. So they multiply to positive 5, and they add up to negative 6. Excellent. So we now know that f of x is really 2x times x minus 5 times x minus 1. That's really helpful, because if I set this equal to 0, that would mean that each of these factors can get set equal to 0. One of them has to equal 0. And then if we solve, we'll see that x equals 0, x equals 5, and x equals 1. That means that we have 3 x-intercepts, we've called those zeros, on our graph. So I'm going to draw a quick little sketch over here. And let's put our zeros on it. So we have a x-intercept at 0. Let's label our numbers on our graph here. So I'm going to go up to 5 in this direction. 5 and 1. Excellent. Now there's two ways of drawing in the graph here. The first way is knowing something about the leading term. So notice that the a value, which is 2, is positive, and the exponent is 3. Okay? I'm going to make a few little notes here about what that tells us. Okay? So if the degree is odd versus being even, okay, the graph is either going to end like this, or like this. So if, see how we had that 2 in front? If the a value is positive, it's going to end like this. Notice I haven't even filled in the rest of this chart here, right? But if this a value is negative, it ends the opposite way. So I'm going to take my arrows, I'm going to put them at the end of the graph. So this one's going to point up, and this one's going to point down. Now you want to connect. And I'm going to obviously go through this point. It has to come up and come back down to go through 1. It's got to go down and start to come back up to get through 5, and then to touch that arrow right there. Okay. We're going to talk about some weird things that happen actually on the graph in the next example. Before I do that, I do want to finish my chart up here. So we did an example with an odd degree and a positive a value, right? What if we had an even degree? Well, this is interesting. If you have an even degree, like 4, both arrows point in the same direction. If they're positive, they're both pointing up, and if it's negative, they're both pointing down. So I'm going to use that chart to help me with the next example. See, here it is. We have an even degree, and notice that the a value in front here is really a 1, which is positive. That means our graph is going to end with both ends pointing up like that. Good to know. But we really need to get those zeros. So I am going to factor this quartic. let's see, what's our GCF? We want to start with our GCF. Don't get fooled by this one. It's not x, it's actually x squared. Let's factor that out. We're left with x squared minus 5x plus 6. Excellent. Let's try to factor the quadratic. Use my x and x to get the x squared. Things that multiply to 6 would be 3 and 2. And if I make them both negative, right, then they'll add up to negative 5. And they'll still multiply to positive 6. Excellent. So now, if you set each of these equal to 0, so x squared equals 0, x minus 3 equals 0, and x minus 2 equals 0, and solve, remember you should get 4 solutions, because our highest exponent was a 4. 2 of them come from right here. We would square root both sides of this equation, and we would get x equals plus or minus 0. Well, 0 isn't positive or negative, right? So we would just say x equals 0. But don't forget that we really had 2 of them there. I'm going to call that a multiplicity of 2, meaning it was repeated twice. Here we have our x equals 3, and here's our x equals 2. All right, I'm going to sketch my graph now that I know the zeros. Okay, so 0, 1, 2, 3. And we also had one at 2. Oh, and let's put our arrows on here now that we know that they're pointing up. Okay. So how do you connect these? Let's see, I'll start from my arrow, go through here, oh, come through, and oh boy, see, we're going to have a problem. We're going to have to go like this to get back up. That's actually incorrect. So I hope you had a pencil and you're going to erase that. And I'll tell you why in a second, now that that's erased. We only want to hit the the x-axis and bounce back up like this, if the multiplicity is 2 or 4 or 6 or obviously any other even number. So notice back here that when we found that x was equal to 0, its multiplicity was 2. That is very special. We want to remember that at this point right here at 0, the graph is going to have a bounce in it. I call it a bounce. You could just say it hits the x-axis and then it starts to change direction if you wanted to. Okay. So I'm going to make a little note of that. If the multiplicity is even, I'm going to say graph bounces off the x-axis. That's obviously not a mathematical term, it's just something that I like to use to describe the graph. So see how we got the bounce right there? Okay, we got to come back down to go through the number, the 0 at 2, and come back up to go through 3, and now we can connect. What I would like you to do right now is try this on your, pause the video, and then type this function into your calculator just to verify that the graph actually looks like this. Okay, so this one's a little bit backwards. This is saying, here's the graph, what's the equation? We're just going to go backwards. It's not that hard. So I'm going to start this time by looking at the zeros on the graph. 0, 1, and 2. Okay. What would the factors have to be to get those zeros? Well, whenever we have an x-intercept at 0, we know that the factor is x or x squared, something like that, or 5x. For 1, that would be x minus 1. For 2, it would be x minus 2. Okay. Notice that the ends of the graph are in different directions, And if you look at your chart, this matches odd degree positive a value. So if you look at your equation here, this, if we put it into standard form, and I'm going to do that right now. Okay, let's multiply these two to get x squared minus x. And then we want to multiply that with x minus 2. So that gets me x cubed minus 2x squared minus x squared plus 2x. So that simplifies to x cubed minus 3x squared plus 2x. There we go. So now that it's in standard form, we can see that this is a odd degree, it's cubic, and its a value is a 1. That's a positive a value. Perfect. We don't need to do anything else. Let's just put our f of x in front. And notice we could have written it in either form. The one on top here, this would be factored form. Or the one on the bottom here would be standard form. And either one is fine. Notice it doesn't say what form our answer should be in. I like either one. Let's try one more example. So we have our zeros. That's the first thing we're going to look at. So negative 2. Ooh, careful with this one. That would mean that the factor is x plus 2. 0 is x. I like to put that in front. And 1. So x minus 1. Now, the ends of this graph are the opposite of the last graph. Look at your chart, and you'll see that this means it has an odd degree and a negative a value. We can fix that very simply. All we have to do is put a negative number in front of this x, like a negative 1. Just put a negative sign. And now remember that this graph is called g of x, and we would be done. Again, I can leave this in factored form, or I can put it in standard form. But I'm going to save some time here so you have some practice.